Hey, let's look at this. Eureka, I have found it. So the crown affair. So a crown is hung from a spring scale and found to have a weight of 8.54 newtons. When the hanging crown is completely immersed in water, the reading on the spring scale drops to 8.09 newtons, so it appears to weigh less. So first off, what is the mass of the crown? Well, remember that the force of gravity is mass times gravity. So the mass will simply be its weight divided by gravity. So, which is 10, right? So 8.54 divided by 10 is 0.854 kilograms is our mass of the crown there. What is the buoyant force acting on the crown? Well, the buoyant force will be equal to its actual weight of the crown minus this apparent weight of it when it's in the water. So we've got an actual weight of 8.54 newtons, and it appears to weigh 8.09 newtons when it's in the water. So that's a difference of 0.45 newtons. Where does that difference come from? That's the buoyant force pushing up on it there. What is the weight of the water displaced when the crown was immersed? Well, that weight is 0.45 newtons because the buoyant force is equal to the weight of the fluid displaced. That's Archimedes' principle. What is the mass of the water that was displaced? So once again, we'll just divide by 10. So the mass of the water there is equal to 0.045 kilograms. What is the volume of the crown there? So this is the first place a lot of people get stuck, and we need our density equation to solve for this. So density is mass over volume. We know how much mass of water we have, and we know the density of water as well. So we can figure out the volume of the water pushed out of the way, but that's equal to the volume of the crown. So let's solve for this volume of water technically. Volume will be mass over density. Our mass is 0.045 kilograms. Density of water is 1,000 kilograms per cubic meter. And so when you work that out, you're going to get a very small number of 4.5 times 10 to the negative fifth cubic meters. That may seem very, very small, but remember that cubic meters is a huge amount of volume there. So what is the density of the crown? So again, people get stuck here. Now we're going to use our density equation again, but the density of the crown will be the mass of the crown divided by the volume of the crown. The mass of the crown, remember, we solved for up here in this part. So that is 0.854 kilograms. And the volume of the crown is the same of the volume as the water that we pushed out of the way. So that will be 4.5 times 10 to the negative fifth cubic meters there. And you'll get a density there when you work that out of about 18,978 kilograms per cubic meter there. Last question says, is the crown made of gold? Cite your evidence. You might be like, well, how the heck am I supposed to know? Well, Google the density of gold. So the density of gold is 19,300 kilograms per cubic meter. So this is less than that. Someone must have diluted, that sneaky crown maker diluted the gold crown with something else there.